All right, so we just looked at scatter plots and we saw how scatter plots help us see relationships between two variables. Now we're going to check out histograms, and we're going to kind of learn a little bit about the statistical model of histograms and how they can help us understand data a little bit better. All right, so what I took was all the open powerlifting data. So it was a huge data set. It was over 100,000 competitors. I broke it down to 65,000 competitors because I just did males and the some male competitors just to make it a little bit easier. So 65,000 competitors, and we're going to look at some histograms from that data. We're going to look at squats and then their totals, so their squat, bench, deadlift totals. So remember, so this column here that we're looking at, this is the total squats in kilograms, and you can see like 145, 150. It's going fast. I moved it really quick. But what I'm wanting you to see here is variability. We learned this in our last lesson on data. Variability is how spread out data is. So we have anywhere from 20 kilograms to 467 kilograms. Competitors squat in that range of weight from 20 kilograms to 467 and everywhere in between. Okay. So remember, variability is how spread out data is. And we can see that it is very spread out here. Okay. Then we have what's called distribution. And this is a new term that I want you to understand. Distribution is how often an event occurs. So we're going to look at how we can see how often somebody squats 20 kilograms or how often somebody squats 467 kilograms. And we see that with a histogram. A histogram is a statistical model, is a visual representation of distribution. So it's represented with these bar charts, and these bars represent a group of people, okay? And we're counting the frequency that something happens. So how often does somebody squat between 20 and 50 pounds, whatever this range is? And it's not very often because people are typically stronger, okay? And they're typically stronger until they get to about this point, right under 200 kilograms. So about 175 to 200 kilograms. And over 30,000 competitors can squat in this range, okay? And then it moves down until we get over here. And there's very, very few people, one person, in fact, that can squat over the 450 kilogram squat total. And most distributions are going to have this kind of bell-shaped curve, okay? Because people tend to perform above average, okay? And then this is about average, and then it's going to drop down, okay? This is the shape that we're typically going to see. Here's another one. This is the men's totals. So the combined total between bench, squat, and deadlift. And it has a similar feature, except it kind of dips back down and goes back up, okay? So this is histograms. Remember, histograms show you the distribution of how the frequency of an event, okay? So how often something happens. Okay, let's look at another one. So the top 100 richest athletes by sport. Now, if we have 100 athletes, the 100 top richest athletes, over 25 of them are going to be baseball players. And then you have like 17 of them that are basketball players, 15 of them that are soccer players, and then about 16 of them that are football players. Okay, so this just shows you the distribution of wealth between sports. So of the richest athletes in sports, okay? And it gives you a group. So your group is baseball. How many of the 100 richest athletes play baseball? Well, we're counting over 25 of them, okay? So histogram shows you the distribution, the frequency of an event. And I hope you learned a lot from this lesson. We're going to move in and look at some of the assignments for this week's assignment. All right, take care.